morning, my YouTube viewers. In this video, what we're going to be talking about is experimental factorial design. And so in order to perform experimental design, you have to carry out 6 steps. So number 1, you're going to define your research objective. Number 2, you're going to define your research methodology. Number 3, you're going to conduct a literature review. Number 4, you're going to develop research design. Number 5, you're going to collect and analyze data. And number 6, you're going to present empirical findings. So what I've done is, in order to do this, I've developed a practice question. So again, this is going to be yield. So you've got a run of 1 to 4, and this looks like it's to do with machinery. And then you've got a temperature of low, low, high, high. And then you've got a pressure yield of low, high, low, high. And then you have a yield of 55, 50, 55, 60, and 70. And so rather than do the data analysis on, on the question, what I did was I did it myself. So you've got your grand mean is an average of D2 to D5, that's your yield. You got your low temperature A is an average F's D2 to D5, and B2 to B5 is low. You've got your high temp A, average F's D2 to D5, comma, B2 to B5 is high. You've got your low pressure B, average F's D2 to D5, comma, C2 to C5 is low. You've got your high pressure B is average F's D2 to D5, comma, C2 to C5 is high. You've got your sum of squares total is sum product brackets D2 to D5 minus F1, that's minus the grand mean, squared. So that's 218.75. You've got your sum of squares A, so you've got a formula 2 times brackets F2 minus F1 squared plus F3 minus F1 squared. You've got your sum of squares B is F2 times brackets F4 to F1 squared plus F5 F1 squared. You've got your sum of squares error is F6 minus F7 minus F8, and that's 6.25. You've got your sum of squares combined, that's F7 plus F8, and that's 212.5. You've got your degree of freedom A, that is your numerator, so it's going to be count A unique B2 to B5 minus 1, so that's going to be 1. You've got your degree of freedom B, which is your numerator, is count A unique C2 to C5 minus 1, and that's 1. You've got your total degree of freedom equals count A brackets unique C2 to C5 plus count A brackets unique B2 to B5 minus 1. So you've got your total degree of freedom as 4. You've got your degree of freedom error, which is your denominator, is F3 minus F11 minus F12. You've got your degree of freedom combined numerator, which is F11 plus F12. You've got your mean squared A, which is F7 divided by F11 is 156.25. You've got your mean squared B, which is F8 divided by F12, which is 56.25. You've got your mean squared E, that's your error, and that's if F14 equals 0, 0, otherwise F9 divided by F14, and that's 6.25. You got your mean squared combined, which is F10 divided by F15, it's 106.25. You've got your F statistic A, which if F18 equals 0, 0, otherwise F16 divided by F18, so it's 25. You've got your F statistic B, so it's if F18 equals 0, 0, F17 divided by F18. You've got your F statistic combined equals F19 divided by F18. And so that's 17. You got your p-value A. So you got F disc brackets F20, F11, F14, and your p-value A is 0.125666. Your p-value B equals F disc, F21, F12, F14, and it's 0.204. You've got your p-value combined is fdisc.rt brackets F22, F15, F14, and that gives you a 1.69. So basically, what we're going to do is we're going to come over here, we're going to say alpha, and your alpha is 0.05, and that is also your significant level. And then a null hypothesis is group A equals 0 and group B equals 0. So FP combined on both group A, your p-value is greater than 0.05, and on p-value B, it's greater than 0.204. So on both the A and the B, you would fail to reject the null hypothesis. And then on your p-value combined, it's still greater than 0.05 of your significance level. So what we would do is we would fail to reject the null hypothesis. And then we're going to say here, like HA, that's your alternate hypothesis. So we're going to say the alternate hypothesis is group A and group B does not equal 0. And then we're going to come over here, we're going to interpret it. So the interpretation is you're going to fail to reject the null hypothesis because the p-value for A, B, and combined are all three greater than 0.05. And then so what I've done is I've made a graph for you to show you the yields. And you can see that the yields, there's not a big difference between the yields, and that's what the p-value is all about. So that concludes this video on factorial design, and the next video is going to be another experimental design. So I hope you decide to watch it.